Actually, topic is prove that flat metric G alpha beta. Okay, flat metric. What is the flat metric? That is G alpha beta. Flat metric. It has a two indices. Okay, but it is invariant under homogeneous Lorentz transformation. That means that will be treated as a scalar. Means zero rank tensor. Zero rank tensor means the scalar. Okay. Yes, I have already told you that if the tensor is zero rank, then that will be a scalar and that will be invariant. If that is a one rank, then that means they are vectors. If they are more than one rank, then if they are multi-rank, then it means that is the outer product of different vectors. Okay, we have already proved all these. Okay, so what is the proof of this? What is the what is the meaning of homogeneous? Yes, homogeneous means if you consider the two transformation. Okay, homogeneous means we know that there are two types of transformation. One is rotation. Okay, this transformation, if we consider that translational transformation, if we ignore if we consider that there is no translational transformation, we consider only the rotation, that transformation will be defined as a homogeneous transformation. And if that is a Lorentz transformation, that means that is a homogeneous Lorentz transformation. Okay, I repeat it. Okay. Zero mean no translational if we consider no translational transformation, we consider only the rotation. Yes, I have already explained it in the previous lecture. Sigma. This is gamma, not sigma. Yes, yes, gamma. Okay, and this is a rotation. I have already explained it in a previous lecture. Actually, there are in Euclidean space there is a two that is R A. In 4 dimensions, this R will be replaced with the this, and A will remain. Okay. Yes. Okay. So, what is the Lorentz transformation? Yes. What is the Lorentz transformation? Yes. What is the Lorentz transformation? I have already explained.
Lorentz transformation.
क्या? I have already the only definition, that is a very simple. Length remains constant in 4D. Last transformation. What was length remains the same. Okay. Okay. After if you move from x to x dash, if you are moving from one frame of reference, you are moving from on this frame of reference, but length remains preserved. There is no change in the length. Okay. Actually, vector length never change. Okay. So what is this? I have already explained that. That is beta column. First, maybe a contravariant and covariant. There is no difference. You may, it is up to you. You may choose covariant may come or a contravariant. Both may come first. Okay. There is no condition कि contravariant पहले आना चाहिए, covariant आना चाहिए. But there is no condition for contravariant or covariant. Which one will become first? But there is condition. The first must be a column indices, and column indices must be contact with the second covariant indices. Okay. First, the first column the column indices must be contact with the second row indices. That if that it can't come row indices, the variable having row indices can't become before the contracting column indices. वैसे तो आ सकता है, लेकिन contracting नहीं आ सकता. ठीक है. So firstly, the indices of the column indices must be contact the row indices. Okay, that must be a thing. Okay, as in the case of the matrices, because these are the matrices. We know that the tensors are the column matrices. Okay, in in flat matrix. Okay. Firstly, we will convert covariant to contravariant, contravariant to covariant to contravariant. Okay, mean this and this. Oh, sorry. And this. Okay. Firstly, we will convert these two. Okay, into contravariant. Okay. So x yes. Gamma. Okay. X gamma. Yes. As x alpha into gamma. How we will convert it? Yes, but it comes here. It must come here because this is the column indices and that's so. Be silent, please. If I say this is equation A. Okay, and for this please beta prime okay, and okay, beta is free indices and gamma, oh sorry, xi is contracting. Okay, yes. Yes, yes. Okay. If I say that this is 1, this is 2. Yes, equation A. Okay. Yes. ये बीटा इज रो एंड दिस इज मैंने इसकी सॉरी ठीक है this method I have also used this method. I mean this is result and this is okay. Okay. Yes. X alpha is equal to gamma. Okay. And gamma alpha. Okay. So this must be come before. Okay. And now it's okay. This is okay. 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 Putting 1 and 2 in equation. Now it's okay. So what will be the result? Yes. Yes. X this X X alpha beta G beta psi. Okay. Gamma column indices is contracting with the row is column indices, alpha is column indices contracting with. Total overall is 0. Okay. No free indices. Similarly, this beta is contracting with this beta. This column indices is contracting with this. So our calculation is true or right up till the end. Okay. There is no confusion. Okay. So also, so that is transform. So that whenever transform, yes, whenever you transform, then there must be introduces the new indices that must that not same as the previous, because that is the new indices. You are moving from one space. I mean, if you are moving from x alpha space, or okay, so the indices will be different. Okay, they must be a different. Okay. And I think from first lecture, when we are transforming, we are old indices are different than from the new indices. Okay, they must be a different, and everything is coming not more than 2. Okay, if any indices is coming more than 2, or if the contraction is not same, if free indices are not same, it means your calculation is wrong. Okay, but here. Okay, now this is the left hand side, there is a unprimed, and at right side is a prime. So we have to convert it into the unprimed. Moving from x to x dash, now we have to move from this way. Okay, yes. So for this purpose, what we have to do? Yes. So we have to convert this and this. Okay, these are the prime. Okay. So B I think, it is up to you. It is your choice. It's, I think B, I always usually prefer to take B corresponding to beta and in this way. Okay. But you may take a L, M, N, X, Y, Z, and theta. That's up to you. So if I consider that is B, that is moving B. Okay. So yes, column. X prime beta. Yes, this is yes, this will be equal to okay. Okay. Oh. No, G we use G to convert covariant into contravariant or contravariant to covariant. But when we are interested to moving from a prime to unprime, we have to use the gamma. This is the rotational in a flat space. Okay. One. Okay. Okay. Yes. Beta. Okay. Okay. So what will be this? B. Okay. Yes. And because this is column and this is row. Oh, sorry. This come here. They must come here. Alpha से A. But and this is an mean it is up to your choice. It is your choice. You may use B, A, whatever. Yes. Yeah, oh, that is homogeneous. I have already explained that under homogeneous transformation. I think you are a bit late. Under homogeneous transformation means we are not considering the translational transformation, and that is zero. You are absolutely right. A is zero, okay? Because okay, you are right. We must write the A, but because we are considering A zero, that's why you are right. Okay. Okay, so X beta prime is beta B X B. This sorry, this must become this is X B B beta. If I say that this is 3, please be silent, 3, or you may say that B1, B2, okay, it's up to you, okay. Okay, and the other is this. Yes. Xi D. Okay. Okay. So D must be contract with the column. Row, free indices row, D is contracting. 4, 3 and 4 put in B. Okay, got it? If we put what will be the result? Yes. Yes, if we put it into this, then X gamma G gamma alpha X alpha, this will be equal to, yes, B beta B sorry 3 year. Okay. Yes, G theta xi beta contracting with the G xi B is contracting with B, column is contracting with the column is contracting with beta, column is contracting with the column is contracting with the right side is 0 rank, left side is 0. Actually, if you remember in the previous, if you visit the previous lecture, we always use this, not we don't use the prime here. Okay, when we take double transformation, then we will use the prime one. But because there will be a different transform, because it is we use the indices of the prime when we are interested to differentiate in different. Okay, actually when we take a move from X to X frame, okay, and we may move from X to X double frame. So there will be a double transformation. Okay. For example, if you are moving from psi to this frame, then the transformation will be this without frame because this is transforming. Okay, and this is first time. That's coming first time. That's why we don't need the prime. Okay. And when we move, even if you use the prime, it will not affect the result, okay? Because it prime don't indicate that is derivative or other anything related, but it is only to differentiate. If you use the prime, then even that is only the telling about the transformation, okay? But we usually use in mostly books we use without prime. But when we move from double, then here we will use single prime, and when move because when actually when we study the quantum field theory or particle physics, there will be not a single transformation. Even in our everyday life, we move from one point to 2 point, second point, second to third, third to fourth, and it's in this way we there is infinite transformation. Actually, we have to take the infinite transformation, but because actually now you are at beginning state, that's why we are considering only the one transformation. Okay, and हाँ जी, प्राइम हम इसलिए यूज कर रहे हैं सिर्फ डिफरेंशिएट करने के लिए. प्राइम इज नथिंग, मतलब अगर मैंने मतलब ये उन्होंने ट्रांसफॉर्मेशन यहाँ मैंने प्राइम यूज किया, अगर मैं इसको यहाँ प्राइम हम अपनी जैसे मैं अमूमन बीटा को बी में कन्वर्ट करता हूँ. हाँ, इस वजह से प्राइम यूज. हम ये भी हो सकता है कि हम ओल्ड में प्राइम लगाया हो, न्यू में ना लगाया हो वो, लेकिन हम यूजली कन्वेंशनली ये करते हैं कि न्यू में हम प्राइम यूज करते हैं, ओल्ड में हम नहीं करते, ताकि हमें जेन में रहे, क्योंकि इस तरीके से तो हमारी कैलकुलेशन गलत हो सकती है, मिक्स हो जाता है, कभी हम प्राइम यूज कर रहे हैं, कभी अनप्राइम यूज कर रहे हैं. ठीक है, दैट्स व्हाई वी यूजली प्रेफर दैट द odd space is representing by the without prime and new space is a prime. For example, sometimes we use A as a first space and B as a second space and C as a third space. If you are moving from A space, B space, and C space, we don't use B as a first space and A as a second space, because it may create a problem for us. Only conventionally, okay, to avoid the confusion. Yes, जी. Yes, column. I have already explained in a previous lecture. If there is a two indices, then we don't need to use the column. Okay, we use the column, so a semicolon only for when there is a one indices to avoid the confusion. For example, actually 1B means semicolon means here is a 1. Okay, so only one row, first row. Okay, so we usually write. Okay, I have explained it. Yes. B is contracting with D. These are the transformation law. Yes. क्या नहीं समझ आए? ये समझ आ गया? Beta. Whenever you take if this is a free, this is column. This row indices will be contracted with this column. This is column, so this must be a row. And column must be because it must come first before the function which have or a matrix which have a column row indices. Okay, got it? Okay, so this is the result. Okay. Okay. Beta is contracting with beta. B is contracting with D. Beta is contracting beta. Xi is xi. D is. So all these at right side, all indices are dummy indices, and same it is true for the left. Okay. Now it's up to you if you are interested, because as I have already explained in the lecture about the dummy indices and free indices, dummy indices can change whenever you are interested to change it. Okay, so it's up to you if you are interested to change the left hand side indices or right hand side indices to compare the coefficient. Okay, so yes, all are. Left side is also a zero rank tensor and right side is also. Okay. Okay, if yes, what we can do, B can be replaced with the gamma. B can be replaced with the gamma, and alpha with D. Replacing dummy indices at right hand side, okay, beta with the gamma, you may also replace the left indices of the left side. It is up to you, okay? But I am changing in the right hand side. Beta is replacing with the gamma, and D is replacing with the alpha. Okay? Yes? So yes. What will be the result? Yes. Yes. X, gamma, G, alpha, gamma, X, alpha equal to beta replaced with the gamma. Okay. B, yes. B replaced with the, yes, that's B, not beta. This is B, yes. B with the gamma and D with the alpha. Okay. B gamma, beta, B की जगह gamma, yes, and G beta psi and psi, D की जगह alpha. Okay. 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 So comparing these coefficients. Okay. No, sorry. X gamma, X alpha. Comparing the coefficient X gamma, X alpha both sides. As we know that all four, 1, 2, 3. Why? How we can? Because why we are comparing the coefficient? Firstly, we have to prove that they are independent. For comparing the coefficient, this is condition. I have already explained. Okay, because all X alpha equal to 0, 1, 2, 3 are independent. We have already proved that. Okay, 0, 1, 2, 3, 4. 0, 1, 2, 3. 0, 1, 2, 3. First component, time component, space component, all are independent. X, Y, Z, and CT, all are independent. So we may compare the coefficient. Okay. So this it means yes. G alpha G gamma alpha is equal to beta gamma G beta sigma psi alpha. Okay. Here you may see that if I this is the as I have already explained that when you write it in the form of contravariant covalent, then actually they are the component of the element of the matrices. But when we write it in the form of the matrix, this is G. Sorry. Okay. This is G. Okay. If I write it in the form of matrix, this is G. This is matrix. But here it is column. Superscript is column. Here superscript is row. Here subscript is row. Here subscript is a column. So if one is gamma matrix, then other will be its transpose. Okay. Yeah, that's okay. So if one is okay, there is one. This is the alpha and gamma and alpha are okay. Beta is cancelling with beta. If beta is cancelling with the beta and beta is coming, this is sigma and sigma. Gamma and alpha are free indices. Gamma and alpha is so that there is no confusion in the calculation. If the free indices are different, then the result will be a different. After comparing the coefficient of these, this become a free. This is the result gamma alpha. These gamma is free indices, alpha is free indices for this equation. Okay, sorry. For this equation, gamma and alpha is a free indices. Here, gamma and alpha is a free index. Okay, got it? Okay, if I say this is a G matrix, the one of these two gamma matrices, one will be a gamma matrix and one will be a no. Both are a gamma matrix. Okay, but here one is here superscript is a column. Here superscript is a row. Okay, if I say this is gamma matrix, then it will be the transpose of that gamma matrix. Okay, so this okay, transpose means column will be converted into the row and row will be converted into the column. Okay, so under this is the homogeneous Lorentz transformation. Under homogeneous Lorentz transformation, there is no transformation law is applying on a G. G is remaining invariant. So that means that is zero rank answer. Okay. Yes. नहीं वो यहाँ जो चेंज करेंगे वहां भी वो चेंज आएगी ना, आपकी बात ठीक है. एक्चुअली हम क्या कर रहे हैं, इसको हम इंडिसेस को नहीं चेंज कर रहे, हम ये बता रहे हैं, देख रहे हैं कि इन दोनों में डिफरेंस क्या है. ठीक है, मैट्रिक्स फॉर्म में इंडिसेस नहीं आता. जब व्हेनेवर यू राइट अ मैट्रिक्स A and B, when you write it when you write it in the form of matrix में आप indices नहीं लेते. जब when you write it in the form of component or element of the matrix, then you use the indices. Actually these are the, अगर आप first lecture को देखें तो all these indices are the actually the representing the element of the matrix. When I have write, if you remember that, if A and B are a matrix, I have not used the any indices. A1, A2, A3. These are the components. B1, B2, Bn. Okay. And we have taken the transpose. If you remember that. Okay. Yes. If you are. You may use the contravariant covariant form, or you may if you are not interested to write it in the contravariant covariant form, then you may write in this way. If that is about our first lecture. Okay. So these are this is always used for the component. Okay. Yeah, identities are elements of the matrices. Okay. So that's why. So this is the form of the matrix. Means G remains the invariant under this. In linear algebra course, you have studied the symmetric transformation and such kind of the transformation. Means if you are taking transformation, one must be a transpose and one if you are taking the matrix of transformation, at one side you will take the matrix itself, and at one side you will take the transpose. You may write this may be also write in this form. You may also write. Okay. So means the under transformation G will remain invariant. There is no change in a G. This G will remain this. If that was a vector, it should be transformed. So it means the indices of alpha and beta. This is not a second. Even it has two indices, alpha and beta. Even then, it is not a tensor of second rank. Okay. If it was a second rank tensor, it must be transformed. There must be a two transformation. It must be transformed like a tensor. Okay.